Hey everyone, in our last video, we went on an epic adventure to go get our soil samples. Now, this time we are taking it to the lab for some pure, unadulterated science. Let's see what our samples hold.
Oh, hello there. Sorry, I didn't see you there. You must be here to talk about soil, right? Okay, well, I heard that you got some soil samples at E.B.'s Landing and in the garden and in the forest and the field, so let's talk about all the different physical properties of each sample. So I've made this chart here, and on the top you can see we have our sample locations, these 4 different samples here, and then on the side we have the traits, the color, the mass, the density, the texture, and the particle size. And I made this chart here so that we can organize all of our data and we can access it more easily and we can start to see some trends and what's really going on here. The first physical property that we're going to look at is color, so let's take a closer look here. The garden soil appears to be kind of a dark brown, and the forest soil, by comparison, is a bit more reddish, kind of a dark red-brown. The field soil, I would say maybe a medium tan color, and the bluff material, probably a light gray. So let's write that down in our chart. In order to measure our next physical properties, we need to talk a little bit about mass and volume. So what we've done here is measure out 100 milliliters of volume, or how much space it takes up in these containers. So each sample is 100 milliliters approximately. That's volume. Now, we also need to measure the mass. That's how much something weighs. And to do that, we're going to use this scale. It's a digital scale, and it measures it in grams. Let's measure the mass of this first sample here. Okay, so I don't want to get the mass of the container, so first I'm going to zero out the scale with an empty container. So first I'll turn it on, power button here, wait for it to zero out, and then you put the empty container on, you press 0. This will subtract the weight of the empty container, remove the empty container, and now we're just measuring the weight of the soil. So it looks like 51 grams. I'm going to go ahead and put that in our chart. Now we're going to take a look at density, the physical property of density.
To help illustrate the concept of density, consider a handful of marshmallows and also an equally sized handful of marbles. Which handful feels heavier? The marbles, right? That's because intuitively you know marbles have a higher density. That is, even though they occupy the same unit of volume, which is 1 handful in this case, marbles have a higher mass and are more compact than marshmallows.
So to calculate density, we first start out with the mass, which we get from this entry in our chart, 51 grams, over volume in milliliters. And we know the volume from earlier. We have 100 milliliters in each of our samples. Now we can simplify that to 0.51 grams over milliliters. So let's do that for the rest of them. Let's talk about soil texture. So I'm just going to dump this right here. Let's check it out. So this is from the garden. I feel like this texture it's really soft. Like I could just roll around in it, honestly, and it feels kind of sandy to me. So let's write that down. All right, let's check out the forest soil. So this is much fluffier, and I would call it spongy, actually. Spongy and splintery. Spongy and woody and splintery. And the soil from the field. Oh yeah. Look at that. This feels very powdery to me. And kind of rocky. We have some rocks in here. I'll write that down. And lastly, we have the bluff material here. Ooh, look at that. Yeah, this is way different. It's very crumbly and pretty angular. Now to look at particle size, we're going to use a handy dandy magnifying glass here and take a closer look at all of these.
Typically, when we say particle size, we're referring to things that are made of rocks, such as gravel, sand, clay, and silt. However, for the purpose of this video, we're also looking at other things, such as organic material. And so effectively, we're also looking at the soil composition, not just its size in this category.
I'm noticing a lot of sandy particles and also a lot of really small, woody, organic material too. And also a few bugs in here. Okay, now in the forest soil, it's almost entirely just made up of this organic woody material. Okay, and then in the field soil, there's these little clumps that if you pinch them and break them apart, it just dissolves. It's a mixture maybe of clay and silt. There's really fine powder there. But also, we do have these pebbles in here, these rounded, pebble, gravelly size pieces. So it's a mixture. Okay, now moving on to the bluff material. If you break these clumps apart, you can just barely make out that it's kind of a silty material here. And if you look closer, this is really cool. There's actually a little bit of stripes that in these blocks.
Here's a pro tip for you. If you take a piece of clay and scrape it across your tooth, it will feel very smooth. However, if it contains silt, you'll be able to feel a little bit of grit.
Science, it's really important to use all of your senses, including your sense of smell. Let's give these a whiff. Oh yeah, that smells really earthy, really composty. You know, that kind of slightly rotten smell. This smells kind of like a tree or like bark on a tree. This smells really dusty, kind of like an old closet. And this actually smells kind of salty, kind of like a fresh beach spray.
In our last video, you probably noticed that the environments that we were taking our samples from were all pretty different. And now that we've filled out our chart, you can get a sense of the fact that the soils themselves are pretty different too. Now, you might be asking why? How did these soils end up this way? Don't worry, this question keeps me up at night too. In our next video, we're going to analyze our chart a little bit more closely and use it to actually design an experiment that you can do at home too. Thanks for watching. See you next time.